Hi, welcome to another 4AC learning video. In this video, we want to look at example 3.8a, which is found in your lecture notes, topic 3. The questions read as follows. Refer to the network given below. A. Calculate the voltage VC using the voltage divider rule. B. Calculate the current IS, is the source current coming out from this voltage source, and find the power delivered to the network. That means how much power comes into here and how much power comes into here. Well, to solve this question, let's first look at A. We want to calculate VC. Now, if you look at this circuit, we actually have two loops. Right, we can say this is loop 1 and this is loop 2. So in order to calculate VC, we need to use loop 2 because VC is actually in loop 2. Right, so looking at loop 2 and using voltage divider rule, we can write the formula VC is equals to the impedance XC over the total impedance along the path, the loop 2 path, which is we call this Z2, multiplied by the total the source voltage, which is alright. So this is based on the voltage divider rule. Now XC is given there as 10 ohms, and since this is a capacitance, I can write it as in phasor form, 10 angle minus 90 degrees divided by the total impedance. Now total impedance is 5 minus 10J. 5 minus 10J is the rectangular version. So if I were to convert that into phasor, that will be 11.18 with the angle of minus 63.44 degrees. Multiply by 60, the voltage, with the angle of 30 degrees. That will give me 600. 10 times 60, 600 divided by 11.18, and the angle is minus 90 here, plus 30, and plus 63.44. That gives me 3.44 volt. That's equals to 53.67 at the angle of 3.44 degrees. Voltage. So that's the voltage across the capacitor here. Alright, to calculate IS, we need to make use of Kirchhoff current law. Kirchhoff current law states that IS is equals to I1 plus I2, which means that we need to calculate I1 which is the current flowing through this loop, and I2 the current flowing through this loop. So applying Ohm's law, I1 is equals to E divided by Z1. That's equals to, in polar version, 30 degrees divided by Z1. So Z1 is 4 plus, because of this inductor, 4 plus J6. Now 4 plus J6 is the rectangular version, which I would like to convert that to the phasor version, the polar version, which is 7.21 angle 56.31 degrees, which is equals to 8.32 at an angle of minus 26.31 degrees ampere. Similarly, applying Ohm's law to the loop 2, I will have I2 is equals to E divided by Z2, which is equals to 60 at an angle of 30 degrees divided by Z2 is, as we saw previously, is 5 minus J10 or 10J, right? And we have also used it here, so it's 11.18 minus the 63.44. So 11.18 at an angle of minus 63.44 degrees. That gives me 5.37 ampere, angle of 93.44 degrees, at the angle of 93.44 degrees ampere. So all we have now is to add up the two currents, and we get the total. So as seen earlier, we have IS is equals to I1 plus I2. So writing out the results, I will have I1 is 8.32 angle minus 26.31 degrees plus 5.37 angle of 93.44 degrees. Now, since these are in polar form, I need to convert to rectangular form because I'm going to add them up. Okay, so converting to rectangular form will give me 7.46 minus J 3.69 plus minus 0.32 plus J 5.36. That gives me 7.14 plus J 1.67. And converting that back to polar form, that will be 7.33 angle 13.19 degrees, which is in ampere. So that's the total current IS. Right now, for the last part, the last question, part C, is to find the power delivered to the network. Now, to find power, we need to work on the formula. Power can be calculated. It's P equals to EI cosine of the angle between E and I, or we can calculate it as P equals to I square R. Okay. So let's do the first one. First one is P equals to E. E is 60 times current is 7.33 cosine of the angle, which is 30 degrees minus 13.19. That's equals to 421 watts. Alternatively, you can calculate power P is I1 square of R1 plus I2 square of R2. That's equals to, now R1 and R2 are actually the resistive component of each loop. So I have I1, which is 8.32 square multiplied by R1. R1 is R1, we have it there earlier on as 4 ohm. Plus I2 is 5.37 square times 5 ohms. That gives us also about 276.9 plus 144.2, which is also 421 watts. That's the answer. Okay, so I hope you have learned something from watching this video. Thank you for watching. Bye bye.